Hello everyone, welcome to session 1 of module 3, Reviews and the Test Process. In this session, we will learn about reviews, which is most important and widely used static testing technique. Now let us first understand what is static testing. Static testing is testing of a component or system at specification or implementation level without executing the code. For example, walkthrough, technical reviews, or inspection. So what this means is you are not going to execute any code. In static testing, as the name suggests, you will just verify whether the specification, for example, software requirement specification or design document, or your code that you have implemented. So you do not execute, because you cannot execute any requirement document or design document. The code you can, but you do not. In static testing, you do not execute any of the test deliverables. You just review them with the help of you can review with the help of some tools. There are static testing tools available to review the code or the documents, but you do not execute any sort of code in static testing. So if you are doing just verifying the document, the specification, the design document, the code without executing, it is known as static testing. Now during static testing, software products are examined manually or with some tools, but there is no execution done. So during static testing, you just examine the software products manually. So you can examine software requirement specification and see whether all the requirements are valid, make sense, are testable, or you can review the design document to see whether the design that has been proposed is proper and feasible to implement by the code. So any sort of examination without execution is known as static testing. In static testing, you can use some static testing tools, which we'll discuss further. Now, static testing helps to verify the software deliverables for which dynamic testing techniques cannot be applied. So, for example, if you have a software requirement specification, SRS document, functional requirement document, functional specification document, or your design document, high level, low level design, or test plan or test strategy document, you cannot apply dynamic testing technique to these kind of documents to verify these kind of documents. So static testing technique is applied to these documents to verify the software deliverables. More about static testing. So static testing technique provides a powerful way to improve software quality. So how static testing technique improves the software quality? So as we have discussed in previous sessions, that suppose there is a invalid requirement and you do not question that invalid requirement in the beginning of the software development life cycle. You design that invalid requirement, then that invalid requirement will get implemented by the developers. It will be coded. You will receive, the testers will receive a build for that invalid or incomplete requirement. That should have been, figured in the first requirements gathering phase itself. Once you receive the build, definitely the expected result that you will get after executing that build or executing that code dynamically and testing it, the actual result, the expected result won't match the actual result, and everything has to be redone. So how static testing technique helps to avoid these kind of situations is from the beginning of the phase itself, you start to verify whether the requirements that you are gathering are valid, are complete, have no ambiguity, and then once all the requirements get finalized, you do not have any doubt in the requirement, all the requirements are clear and testable, then those requirements are designed, they are implemented. A design document is being created, and then that reviews or static testing technique is used to review that design document to ensure that design is as per the requirement. Requirements are being met by the design. So since you are applying static testing technique from the beginning of the phase itself, you are removing the defects that can be introduced from the initial phases of the software development life cycle. So since you are removing the issues from the initial phases, it will eventually improve the software quality, because you will be able to figure out issues in the early phases of the SDLC itself. So objective of static testing technique is to improve the software quality by assisting developers to recognize issues early in SDLC. So main objective of static testing is to improve the software quality. So once you review the documents in the initial phases of SDLC, in requirements in design phase or in the coding phase itself, so once you review those documents, once you review the code, that the actual code that has been implemented by the developer meets the coding standard, follows all the defined development procedures and process of the organization, then you ensure that minimal defects or minimal issues are being introduced in the build or are found in the testing phase. So objective of static testing is to remove all those issues that can get introduced due to bad design, due to bad requirements or bad coding standards. Static testing technique or static testing is not a replacement of a dynamic testing. So dynamic testing has another purpose and static testing has another purpose. So none of one cannot replace the other one. So both have to be done in different phases of software development lifecycle. So all organizations should implement static testing technique to improve software quality. So in order to improve software quality, static testing technique is the most important testing to carry in any sort of software development lifecycle. Now let's see the difference between static testing and dynamic testing. Static testing examines software deliverable without execution. That's the first difference. And dynamic testing verifies the software by executing it. So static testing is up to your code, up to the coding phase. But dynamic testing starts when developer builds that code into some sort of executables and gives that executable to the testers, which can be installed on the servers and executed, where from then on dynamic testing starts. Static testing finds the cause of failure. So static testing, main purpose of static testing is to find the cause of failure, and dynamic testing finds the failure. So when you install the software on a server, when you start executing it, you are doing dynamic testing, and anything before installation or up to the coding phase, wherein you are not executing the code and just verifying the code and requirements manually, is a static testing technique. So static testing finds the cause of the failure, and dynamic testing finds the failure. Now static testing technique is known as verification. and dynamic testing technique is known as validation. So let's see from the V model where static testing fits and where dynamic testing fits in the V model. So here's the V model. So if you see the V model, so it starts from the requirements, then system requirements, then global design, detailed design, and then implementation. And then in the right hand side you have unit test, integration test, system, and acceptance test. So static testing, any testing which is in the left side from the requirements or system requirements or in the design phase is all static testing. If you see here, this is all sort of testing that is done for the requirement, software requirement specification for the design documents, like high level design for low level design documents, or the code or the actual code that is being implemented. If you are reviewing the code without executing it, all that thing is static testing. Once the code has been built and available in the form of builds which can be installed on the servers, and then a unit testing starts by executing the code. It is installed on the server, and then the code is kind of executed, deployed and executed. From then on, the dynamic testing phase starts. So in the V model, in the left hand side, it's all static testing, and the right hand side of V model is all dynamic testing. So now static testing technique, let's see the static testing technique that is reviews, which is very widely used in organizations for doing static testing. So an evaluation of a product or project to ascertain discrepancies from planned results and to recommend improvements. So what does review do? It just evaluates the product or project to ascertain that the discrepancies from plan and to recommend improvements. So main purpose of review is to evaluate any sort of document, that software artifact, like the reviews or the design document. So you review them and you try to find any sort of discrepancy, and if there is any discrepancy, you recommend improvements. So type of reviews can be informal review, technical review, inspection, and walkthrough. So these are all different kind of reviews. So review is a static testing technique and tests the software products without executing them, and can be performed before dynamic test execution. So review is always performed before dynamic test execution, and review is a static testing technique. Objective of reviews is informational, educational, where participants learn about software, work product, and plan for future work according to their role. So the main purpose or objective of review is to get information, more and more information or education on the software work products, like requirement specification or a design document, and then plan their future work according to their role. Then defects found by reviews are cheaper to fix, as they are found early in SDLC than those detected during dynamic testing. So any defects that are found in reviews are very cheap to fix because you haven't gone into further phases of SDLC. So as we have discussed in first chapter itself, that if you introduce a defect in requirements and that passes on to design, then to coding, and is found into testing phase, the cost of fixing that defect is very high. So you have to reinvest in all all the resources that you have already, initially you have done a design, invested funds into coding that wrong design. So in case defects are found in later phases, the cost of fixing those defects is very high. But using the static testing technique, using reviews, since the defects found by reviews are in early in software development life cycle, so it is very cheap to fix those defects, because fixing a review defect is just changing your document, either your requirement document or your design document, because you find the issues in the document itself, and you just change the document as per the discussion or as per the fix discussed before going further with the implementation phase. So if you are doing reviews, it is always cheaper to fix defects that are found in the software artifacts. Now, typical defects found by static testing. Let's see what kind of defects can be found by static testing. So invalid or incomplete requirements, which is the first phase of SDLC. The very first phase is to gather the requirement, the client requirement, or the requirements from the market if you are developing some out of the box kind of application which will be used by mass market. So in case the requirements are invalid or incomplete, you will, if you're doing review or static testing technique, you will be able to find whether the requirement is valid or incomplete, and then you will be able to also find untestable requirement. So I'll take an example to explain what sort of questions you need to ask in order to find whether the requirement is testable or not. So suppose there is a requirement for an e-commerce website which says the system should respond quickly. That's a very generic requirement. System should respond quickly. But with this statement, you cannot test it. There is no baseline against which you will produce your test results. So this kind of requirement, if you find any ambiguities or incomplete information, you can question and find the exact requirement that is testable. So in this case, the system should respond fast. This is not testable. In order to clarify it, so what sort of questions you can ask is, what sort of response are you expecting? I mean, for how many users, what sort of response time are you expecting? So the more testable requirement for this kind of performance would be, suppose there are 100 users logged in on the system at the same time, concurrent users at the same time. The response time of the e-commerce website should not be more than 5 seconds. So that is more testable rather than just saying system should respond fast when there are multiple users on the website, because you don't know how many multiple users are there, and you don't know what should be the response time. So you need to clarify how many users have to be there at the same time, and what should be the response time. So you figure out these sort of untestable requirements as well by reviews. Then you also find any incorrect software or system design. If the design is not implemented, if the design is not proper, software design or system design is not proper, then you are able to find those kind of issues in reviews as well. Then if there are any incorrect UI design, you have you are developing an e-commerce application, e-commerce website, and you are reviewing the UI design. So in case there is something missing in the UI, or there is some incorrect UI, that can also be found, or deviations from any regulations or standards. So whenever you are doing a software development, there are many standards and regulations that need to be followed nowadays. For example, accessibility. If you are developing an application for specific, so accessibility standard has to be met. Or if it is an application for a government organization, it has to follow some regulation or standard. So these kind of deviations can also be found by reviews or by static testing. Now, software work products tested by static testing. What kind of software work products you can test by static testing? Can be software requirement specification document, SRS, your design document, high-level design or low-level design document, your UI specification documents, which specifies how your UI should behave, what should be the flow once you log in on the website, how the flow should happen, or the UI wireframes, the look and feel of the website, how the things had to be aligned on the website. You can test UI wireframes as well by using static testing. Software code itself, without doing without executing the code. So you can just review the software code by either peer review or in the formal review process, and see that software code follows the standards. Then you can also review the test strategy, test plans, test cases, and any sort of manual and automation test scripts. Then any other guides like install guides, quick reference guide, or user guides. All these sort of software, any software work product, any documentation or code can be reviewed, can be tested by static testing. Now, what are the advantages of reviews? The first advantage is early defect detection and correction. So since static testing starts early, it is cheaper to fix defects in earlier stages, like in requirements and design documents. So since static testing starts very early in the software development life cycle, so in case you find any discrepancies in requirements or in design, you are able to find those discrepancies in very early phases, and it's very cheap to fix those defects in earlier phases. Then early feedback on quality issues. Now, since static testing starts early, so feedback on quality issues is established early. So since you start static testing in very early in SDLC, so if you have the requirements which are not captured very properly, they have a lot of issues, then you start getting early feedback that yes, we haven't captured the requirements properly. So you get early feedback on any quality issues of the software. Then less rework costs. Since you start testing very early, so if a defect is found in requirements phase, in design phase, or even in the coding phase, it is very easy and quick to fix that defect, rather than it moves to testing and then deployment and maintenance phases, which makes it very difficult to change all the design and then recode and retest. So if you are doing reviews, it is very easy to find the defects and very less rework costs. Then increase in development productivity. Less rework is required, which increases development productivity. So because of less rework, it increases development productivity. Since you are refining your document, you are trying to remove as much defects as you can in requirements phase, in design phase itself, which removes most of the defect and doesn't introduce, because of those fixes there are very less defects that get introduced in during the development phase. Since there are less defects found in the testing phase, so which reduces development rework. So suppose you have developed a software which has 500 issues to fix. Then in order to fix those 500 issues, development team has to keep on looking at those issues, fixing. But in case you have figured out and eradicated all those issues right from the beginning of the SDLC, right from requirement phase and design phase itself, then during the coding phase, the number of defects that will get introduced into the testing phase will be very less, which will reduce the rework of the developers, and it will increase the development productivity. Then reduction in dynamic testing time frame. Since there are very less defects, so since most of the issues are rectified at earlier stages, good quality code is delivered which has fewer issues, and since there are less issues, it's very quick to test that code and save time and cost of defect fixing. Then reduced cost in maintenance activities. So since most of the issues are resolved in earlier phases, post-implementation issues are very less, which reduces maintenance cost as well. So since you have reviewed your requirements and your design documents properly, and most of the issues have been eradicated, have been resolved from initial phase itself, which did not introduce much defects into testing, and if there are some defects introduced in testing, those got fixed, retested. So eventually when you deploy the final code into the production environment, there are very few maintenance issues that will occur, and which will reduce your post implementation or maintenance cost very much, which will reduce which will make your maintenance costs very less. So that's it in this session. So in next session we will look into more about the review techniques and how the review process works. Thank you.